Something strange is happening on Jupiter, and scientists are only just beginning to understand how unusual these changes really are. For decades, this massive gas giant has been known as a symbol of stability in our solar system, with its iconic swirling storms and powerful magnetic field behaving in ways scientists believed they understood. But recent observations have started to challenge that confidence. New data coming from telescopes on Earth and missions like NASA's Juno mission are revealing patterns and behaviors that simply do not fit with existing models. Massive storms appear to be shifting in unexpected ways. The planet's atmosphere is showing signs of dramatic temperature variations, and its magnetic field is behaving far more irregularly than scientists predicted. These changes are not just minor fluctuations. They suggest that something deeper is happening beneath the thick clouds of this giant planet. For a world that is over 300 times more massive than Earth, even small changes can signal enormous underlying forces at work. Researchers are now questioning long-held assumptions about how gas giants function, and Jupiter is quickly becoming one of the most mysterious objects in our cosmic neighborhood. What makes this situation even more fascinating is that Jupiter has always been considered a kind of natural laboratory for understanding how planets form and evolve. If something is changing there, it could mean that our broader understanding of planetary science needs to be updated. The giant storms that swirl across its surface, including the famous Great Red Spot, have been observed for centuries. Yet even these familiar features are now showing signs of transformation. Some are shrinking, others are changing color, and new storm systems are emerging in places scientists did not expect. At the same time, the planet's powerful magnetic field, one of the strongest in the solar system, is displaying unusual asymmetries that cannot be easily explained. These findings are pushing scientists into uncharted territory, forcing them to reconsider theories that have stood for years. As more data continues to arrive, one thing is becoming increasingly clear. Jupiter is not as predictable as we once believed, and the deeper we look, the more questions we uncover. As scientists dig deeper into the strange behavior of Jupiter, the mystery only seems to grow more complex and more unsettling. One of the most surprising discoveries in recent years involves the planet's atmosphere, which was once thought to be relatively well understood. Instead of remaining stable, different layers of Jupiter's atmosphere are now showing dramatic and uneven changes in temperature, with some regions heating up while others cool down without any clear pattern. Data collected by NASA's Juno mission has revealed that powerful jet streams are shifting their speeds and directions, causing storms to behave in ways that scientists did not expect. These jet streams, which help shape Jupiter's iconic bands of clouds, appear to be interacting with deeper atmospheric layers in ways that are still not fully understood. Even more puzzling is the discovery of intense bursts of energy and unusual wave patterns rippling through the planet's upper atmosphere, suggesting that forces from deep inside the planet may be influencing what is happening far above the clouds. On top of that, massive storms are not just changing shape, but also forming and disappearing more rapidly than before, as if the entire atmospheric system is becoming more dynamic and unpredictable. Some researchers believe that these changes could be linked to heat rising from Jupiter's core, while others suggest that external factors, such as interactions with solar radiation or charged particles, might be playing a role. What makes this situation even more intriguing is that Jupiter does not have a solid surface like Earth, meaning that all of these processes are happening within layers of gas and liquid that extend thousands of miles deep. This creates a complex environment where energy can move in unexpected ways, making it extremely difficult to predict how the planet will behave. As scientists continue to analyze incoming data, they are beginning to realize that Jupiter's atmosphere may be far more sensitive to internal and external influences than previously believed, raising new questions about how gas giants function not just in our solar system, but throughout the universe. Beyond the chaos in its atmosphere, the most puzzling changes on Jupiter may actually be happening in something we cannot even see directly: its immense and powerful magnetic field. For years, scientists believed they had a solid understanding of how Jupiter's magnetism worked, driven by the movement of metallic hydrogen deep within the planet. However, new measurements from NASA's Juno mission have revealed that the magnetic field is far more uneven and strangely shaped than expected. Instead of being relatively smooth and symmetrical, it appears distorted, with certain regions showing intense concentrations of magnetic energy, while others seem unusually weak. This imbalance has raised serious questions about what is happening deep inside the planet, in layers that are impossible to observe directly. Some scientists now suspect that Jupiter's internal structure may be more complex than previously thought, with turbulent flows of electrically charged material creating unpredictable magnetic effects. Even more surprising is the discovery that parts of the magnetic field may be changing over time, suggesting that the processes inside Jupiter are not as stable as once believed. This kind of variability is something scientists associate more with smaller planets like Earth, where magnetic fields shift slowly over long periods, not with a massive gas giant that was expected to remain relatively consistent. The idea that Jupiter's magnetic field could be evolving adds another layer of mystery, hinting that the planet's interior might be undergoing changes that we do not yet understand. These magnetic irregularities also have visible effects, especially near the planet's poles, where powerful auroras, far more intense than those on Earth, are behaving in unusual ways. Instead of forming stable glowing rings, these auroras flicker, pulse, and sometimes appear in unexpected patterns, as if responding to hidden forces beneath the surface. The deeper scientists investigate, the more they realize that Jupiter is not just a giant ball of gas, but a dynamic and ever-changing world with secrets buried far below its clouds. And as each new discovery challenges what we thought we knew, it becomes clear that Jupiter may hold clues not only about itself, but about the fundamental nature of planetary systems across the universe. As these strange discoveries continue to unfold, scientists are beginning to consider a more unsettling possibility. What if the changes on Jupiter are not isolated events, but part of a much larger and more complex transformation? This idea has started to gain attention as researchers compare recent data with observations collected over decades, noticing patterns that suggest long-term shifts rather than short-term anomalies. Information gathered from missions like NASA's Juno mission, along with powerful Earth-based telescopes, shows that certain atmospheric features are evolving in ways that cannot be easily explained by existing theories. Some scientists believe that deep within Jupiter, slow but powerful changes in heat distribution could be driving many of the unusual surface behaviors we are now seeing. Others suggest that interactions between the planet's magnetic field and charged particles from the Sun may be creating feedback effects that influence both the atmosphere and the auroras in ways we do not yet fully understand. What adds to the suspense is that these processes may be connected, meaning that a shift in one part of the planet could trigger a chain reaction throughout its entire system. This raises an even bigger question. If Jupiter, the largest and most dominant planet in our solar system, is undergoing changes we cannot fully explain, what does that mean for our understanding of other gas giants beyond our cosmic neighborhood? The possibility that Jupiter could be entering a new phase of behavior challenges long-standing assumptions about planetary stability. It forces scientists to rethink how these massive worlds evolve over time, and whether similar changes might be happening elsewhere without our knowledge. As more data is collected and analyzed, researchers find themselves in a race to understand what is truly happening before more unexpected changes occur. Each new discovery seems to open the door to even deeper mysteries, creating a sense that we are only seeing the surface of something far more complex. The idea that Jupiter could still surprise us after centuries of observation adds a sense of urgency and excitement to this ongoing investigation, leaving scientists and space enthusiasts alike wondering what revelation might come next. As the mystery deepens, scientists are now exploring the possibility that what is happening on Jupiter could have far-reaching implications beyond just one planet. Jupiter has always played a crucial role in shaping our solar system, acting like a massive gravitational shield that influences the paths of asteroids and comets, and possibly even protecting planets like Earth from frequent impacts. If Jupiter itself is changing in unexpected ways, it raises important questions about how stable that protective role really is over long periods of time. Researchers are beginning to examine whether subtle shifts in Jupiter's internal dynamics could eventually affect its gravitational influence, even if those effects might take thousands or millions of years to fully unfold. At the same time, the strange behavior observed by NASA's Juno mission is forcing scientists to reconsider how gas giants behave not only in our own solar system, but also around distant stars. Many of the exoplanets discovered so far are similar in size to Jupiter, and they are often used as key examples when scientists build models of planetary systems. If our understanding of Jupiter is incomplete or flawed, then those models may also need to be revised. This adds a layer of urgency to the research, as astronomers realize that unlocking Jupiter's secrets could help them better understand the countless giant planets scattered across the galaxy. Meanwhile, the continuous stream of new data is revealing small but significant details that hint at deeper processes still hidden beneath the clouds. Subtle variations in temperature, unexpected movements in atmospheric bands, and unusual magnetic signatures all point toward a system that is far more active and interconnected than previously believed. Some scientists even suggest that Jupiter may be experiencing cycles of change that take decades or centuries to fully develop, meaning that what we are witnessing now could just be one phase of a much larger pattern. This possibility adds both excitement and tension to ongoing research, because it means we might only be seeing a small part of a much bigger story that is still unfolding. As the investigation reaches its most intense phase, scientists are confronting the reality that Jupiter may be far more mysterious and dynamic than anyone imagined. Every new observation seems to raise more questions than it answers, from the shifting storms and unpredictable jet streams to the puzzling distortions in its magnetic field. Researchers are now realizing that these phenomena are likely interconnected, forming a complex system in which changes in one layer of the planet ripple through others in ways that are difficult to predict. This interconnectedness suggests that Jupiter is not simply a static giant in our solar system, but a living, evolving world, with processes operating on scales that challenge human understanding. The suspense builds as each new dataset from NASA's Juno mission uncovers phenomena that existing theories struggle to explain, reminding scientists that even the largest planet in our cosmic neighborhood can still surprise us. At the same time, astronomers and planetary scientists are racing to model these changes accurately, using supercomputers and advanced simulations to anticipate what might happen next. Their work could have implications far beyond Jupiter, helping us understand not only other gas giants in our solar system, but also the thousands of similar planets orbiting distant stars across the galaxy. While the mysteries of Jupiter may never be completely unraveled, the very act of discovery is pushing the boundaries of human knowledge, inspiring curiosity and wonder. Each new finding invites us to look at the universe with fresh eyes and reminds us that even familiar giants like Jupiter can hold secrets capable of rewriting what we thought we knew about planets and space itself. If you're benefiting from our topics, please subscribe, like, and turn on the bell notification so you can see our new videos early.